Well, hey guys, in this video, we're going to talk about logic some more. And namely, what we're talking about is writing truth tables, joining two or more statements together. Now, this does have sometimes this is called Boolean algebra, and we're going to kind of, I want to say skim the surface. I'm not going to say we're going to go into it too deep, but you do need to know it has applications in computer science, of course. There are probably applications in logic for English, for law, for things of these natures. So just keep that in mind. And so the first thing that you need to know about a truth table is that it's a way to organize the truth values of a statement. And this becomes easier to look at than just considering all the possibilities out there when you have a lot of things going on at one time. So this is a way to organize information that helps you understand what is happening in a appealing visual format, if you will. Okay, well, let's go on to the next slide. So we're going to talk about a single statement truth value. That means if you take one statement, what are the possibilities of the truth values for one particular statement? Okay, and so we're going to take a look at this. I'm going to do this in this example, I'm going to show you what this looks like by comparing a statement against its opposite statement, which means I'm negating the statement. Okay, so when we take a look at a statement piece, and the statement can be anything. Don't worry about what the statement is. Just consider if you have some random statement P and its truth value is true, then the opposite of its truth value is false, of course. And so the opposite statement, which is not P, would be false. So you're going to notice that in this single statement truth table, you have two possible outcomes, true or false. So if the original statement is true, then its opposite value is false. Okay, so just remember, one particular statement has two possible outcomes. Now we're going to continue this, and we're going to begin to join two or more statements together. And what we're going to do right here is we're just going to join two statements together to get you a feel for how this works. Whenever you join two or more statements together, these statements that have been joined together form a new statement. And so this is where the truth table really helps you, because you begin to have a lot of different possibilities. Now, there's something you do need to know. Okay, if you join two statements together, then you double the number of possibilities. Remember that when you just have one truth statement, there's only two outcomes, right? But when you join two statements together, you have double the number of outcomes. So there's 2 times 2 outcomes. So whenever two statements are joined together using logical conjunctions or disjunctions, now there are 4 potential truth outcomes. If you join 3 or more statements together logically, well, now you've got 2 times 2 times 2, so 8 possible outcomes. So of course, the more number of statements that you add or join together, your possibilities begin to double. Okay, so keep that in mind. Now, we're not going to go real heavy and deep off into that, but you do need to understand why some truth tables only have 2 possible outcomes, why some have 4, why some have 8, some have 16. Notice the only numbers I'm using are doubles of one another, right? 2 times 2 is 4, and so on. But let's take a look at the word conjunction. So conjunction is when you join two statements together with the word and. As an example, today is July the 28th and it's Tuesday. I've joined two statements together. One statement is today is July the 28th. The other statement is it's Tuesday. Okay, I've joined them together with the word and, so keep that in mind. Now, when you're talking about symbolically, well, what does that look like on your paper? Whenever you see that upside down V, you might have called that a hat. Some teachers call it a hat, upside down V, whatever you want to call it. I don't care. Just know that that symbol means and so you're joining two things together with the word and symbol. Okay. And so if I want to join, say I've got a statement P and a statement Q, and I want to join them together by saying P and Q, that's going to make a truth table that looks like this. And notice now that compared to the first truth table I had only two truth values, but on this truth table, I have four potential truth values. I have four rows instead of two. And the reason is I'm joining two statements together. So there's 2 times 2 total possibilities for a total of 4 different possibilities. Of course, my new statement is P and Q. So whenever you're joining two statements together logically with the word and, in order for the new statement to be true, both P and Q have to be true at the same time. So whenever you're joining together logical statements, you can see there's only one outcome for which P and Q is true, and that is when P is true and Q is true. Nothing else will make this statement true. Now, if I want to join together two statements with the word or, it's called a disjunction. And a disjunction basically flips that hat or that carrot or whatever you want to call it upside down. It kind of looks like a V there. And that is called the or symbol. Now, notice when I look at my truth table there, I'm joining two statements together with the word or. And as I take a look there are 3 possibilities where the new statement can be true and only one possibility where it's false. So the new statement is P or Q. As long, if I'm joining together two statements together with a disjunction or an or symbol, as long as one of the statements is true, the whole statement is true. So if P and Q are true, then P or Q is true. If P is true but Q is false, the statement P or Q is still true. If Q is true but P is false, the statement is still true. The only way that it's not true is if they're both false. So that's the way the disjunction works, the upside down V. And then, of course, finally, we have the implication arrow. We're going to be dealing heavily with the implication. That's joining two statements together with the words if and then. So as you take a look here, this little arrow means if P, then Q. That's called the implication arrow. And arrow, not that's what that little arrow means. And so it's the implication symbol. So if I've given you two statements, P and Q, well, the new statement is if P, then Q. Okay? Now notice the only time that this is false is if the P is true and the Q is false. We're not going to go real heavy into this implication part only because we're going to deal with that very heavily when we get involved with conditionals. But what you do need to see is notice the organization of this particular truth table. This is the implication. So, of course, in this particular video, we've covered conjunction, disjunctions, and implications. And these are very important to truth tables and Boolean algebra. Thanks for tuning in.